So last week we covered things about integration over regions inside two-dimensional space and regions inside three-dimensional space. But the one we're going to talk about today is another type of integration that has a slightly different flavor, and that has to do with the concept of arc length. So if we've got a curve that's moving inside 2D or 3D space, we'd like to be able to say how we calculate its length. And there are old versions of that in single variable calculus. There's a formula for the length of the graph of a function, and it's given by this lovely integral down here, which we may or may not recognize, and we may or may not have any understanding of why that formula works. So if we'd like to move on, we have to understand exactly how we calculate lengths of things in 2D that aren't necessarily graphs, and lengths of things in 3D that, are not really potentially given by anything even like a graph of a function at all. The main idea of this is that if we have a parameterized curve, we don't need to know what direction it's moving. We can just calculate the distance it moves, and the rate of change of distance is speed. If we're going at 75 miles an hour for 2 hours, we go 150 miles, full stop. Doesn't matter what direction we're moving, etc., etc. So to calculate the total distance we traveled, we multiply speed by time if our distance is constant. But if the speed fluctuates, we should instead integrate. And so to put that into formulas, if we have a parameterized curve, c of t, we already talked about how its speed is given by the length of its tangent vector, the length of c prime of t. That calculates the speed in terms of the length of velocity, and so our total distance traveled from time A to time B is the integral from A to B of the length of c prime of t. That calculates the arc length most of the time. To find the arc length of a curve in space, we parameterize it, then we calculate the distance traveled by the object that moves kind of from one end of the curve to the other. And it doesn't depend on the parameterization. Some versions of parameterization are easier than others to do calculations with, and we'll see that as we go on.